මේ හතරවෙනි මෙතඩ් එක බින්සන්. හරිද? මේ composition එක express කරන හතරවෙනි මෙතඩ් එකට අපි දාලා තියෙන්නේ මේ fourth method is the expressing the composition of a liquid mixture. Fourth method එක expressing the composition of a liquid mixture in terms of mass over volume. In terms of mass over volume. Right, expressing the composition of a liquid mixture in terms of mass over volume. Right, so the general equation for this composition of a liquid mixture equals mass over volume. So now if you are talking about a liquid mixture, in a liquid mixture there would be like two things definitely, a solvent and a solute, right? So when you talk about a solvent and a solute, definitely the mass of the solute will be measured. When you talk about the mass in a solution, the solute's mass will be measured as the mass, and the volume of the solvent will be measured in volumes, right? The solvent amount will be measured in volumes. So mass means mass of the solute. Mass of the solute. Okay, and then volume means the volume of the solvent. Volume of the solvent. Okay, so this is how we indicate the composition of a liquid mixture in terms of mass over volume. So in mass we indicate the mass of solutes, and as a volume we indicate the volume of the solvent. Okay, so we need to know about this volume a little bit. So simply mass is measured in chemistry. Now you all know the SI unit of mass, standard international unit to measure mass is kilograms, but in chemistry we use grams to measure the mass of chemicals. And then when you talk about volume, we basically use a decimeter cube as the unit to measure volume. Okay, so you need to copy down all of these. We use a decimeter cube to measure the volume of solvent, right? And then we have to know the relationship between the milliliters, centimeter cubes, and the decimeter cubes. All right, so after writing this, you have to know the relationship. Now 1 centimeter cube is equal to 1 decimeter cube. Actually that is 1 centimeter cube is equal to 1 milliliter. Sorry, 1 centimeter in a 1 centimeter cube of a space, in 1 centimeter cube of a volume, you can store 1 milliliter. Okay, so then 1000 centimeter cubes would be equal to 1000 milliliters. So you can understand 1000 milliliters is 1 liter, and that's equal to 1 decimeter cube. Okay, that means simply 1000 centimeter cubes is equal to 1 decimeter cube. Okay, so in 1000 decimeter cube of a volume, you can store 1 liter of solvents, 1 liter of liquid, 2000 milliliters of liquid. Simply note it down. And then I gave a sum, right? I gave a sum. As I can remember, 4 grams of salt is dissolved in 2 decimeter cube of water. Express the composition as mass over volume. Right, mass over volume. This was the question. right? So then composition equals mass over volume. So mass is 4 grams in 2 decimeter cubes. So simply we'll get the simplification as 2 grams per decimeter cube. 2 grams per decimeter cube. Make our bima. And then the next method, fifth method of indicating the composition is expressing the composition of a mixture. Expressing the composition of a mixture in terms of moles over volume. Expressing the composition of a mixture in terms of moles over volume. Expressing the composition of a mixture in terms of moles over volume. Fifth method. Okay. So, sorry, expressing the composition of a liquid mixture in terms of moles over volume. Expressing the composition of a liquid mixture in terms of moles over volume. So here we're going to indicate the composition as moles over volume. So this method of indicating the mixture, liquid mixture, this method of indicating the composition of a liquid mixture in terms of moles over volume, composition of a liquid mixture, right? This method of indicating the composition of a liquid mixture in terms of moles over volume is called indicating the concentration of a solution, right? Concentration. We call this method as a concentration. I mean, may vidhiyata indicate karnakota composition එක we call that we are expressing the concentration of a mixture, right? Concentration of a liquid mixture. So copy it like this, and then we have to write a point under this. Expressing the composition of this way of expressing the composition of a liquid mixture, which means as a moles in terms of moles over volume, is called the concentration. It's called indicating the concentration of a solution, right? Right. So you can write the point. Expressing the composition of a homogeneous liquid mixture. Expressing the composition of a homogeneous liquid mixture. Expressing the composition of a homogeneous liquid mixture. Expressing the composition of a homogeneous liquid mixture in terms of moles over volume. In terms of moles over volume. In terms of moles over volume. Is called expressing the composition. It is called expressing the concentration. 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 So in this case, concentration C indicates concentration, right? Concentration, you need to note it down. That is indicated with the units of moles per decimeter cube. N in the equation indicates number of moles as a mole, right? And V indicates volume, that is measured in decimeter cube. So our final equation in the simplest version will be concentration equals number of moles over volume. So actually the standard form of this equation is N equals CV, but the same thing in this N is subjected, here the C is subjected. That's not a fact to worry about, but just make it like this. So in this equation, concentration is indicated in moles per decimeter cube, N is indicating the number of moles, and V indicates the volume of the solvent. So hereafter we have to calculate some, do some sums, right? to get the exposure how this equation work. Okay, that's it. After that, the thing is done. Lamai Harida, I think y'all the last day also last day we couldn't come up to this point.
Yes, sir.
Yeah, okay, right. Me other Elisha mute the Anangi Shanu.
So I'm there.
Are there? Pekka, are you there?
Yes, sir, I'm here.
Shape. Right, okay, Hari. Harane, Urbani Tahanone.
Yes.
Okay, right, Hari, make a. So I'm gonna give you some questions. Now we will be doing some questions in the order of that they're getting like a little bit difficult, right? So what I suggest to you is to copy down these copy down the question and then just go for a diagram, right? So then diagram in the sense a small sketch, so then it will help you to understand what facts are given in the question and what facts, I mean, what do they want you to find, right? Because now you will understand when this is going on that you will have to sometimes deal with two type of equations, right? So I'll just come up with those questions and then you'll understand and let's discuss. Find the first question. Find the first question. 2 moles of 2 moles of 2 moles of 2 moles of sucrose is dissolved in 4 decimeter cube of water. 4 decimeter cube of water. Express the concentration of the solution. Express the concentration of the solution. So what I have given you, go for a small sketch. But I've given you what 4 decimeter cube of water. Okay, that I've given you, right? So then I have given you how much of moles, 2 moles of what? Sucrose, right? That's what I've given you. So I know the number of moles, that is 2 moles. I've given you the number volume, that is 4 decimeter cube. So what am I asking from you is the concentration. So you can simply do the math and get the answer. Concentration equals number of moles. So volume, number of moles, I've given you 2 moles. That's very simple. Volume is 4 decimeter cube. So then you'll get 0.5 moles per decimeter cube is the concentration of this solution. Is it clear? That's very simple. The sum is very simple. That's what I actually did it. I'll not be doing the things what I'm asking in the next few questions. I'll let you to do them. Right? Make it other. Right? It's very simple because when you go for a sketch, you know what they have given you and what they are asking you to find out. Right? Otherwise, you don't have you will find it difficult to what actually is given in the sum and what actually the sum asks from you. Right? And then you will in a mess. You'll be in a mess. So don't put yourself into that situation. Just note it down what they really ask from you. So with the given data, you can manage the question well and get the answer easily, right? Okay. So done, the guys. That is question number 1. Now I'm going for a few questions, right? That's question number 1. Are we done with that?
Yes, sir.
Right. What about the others?
Okay, sir.
Right. Okay. So the next question now. Okay. Now the thing is number of moles. I gave it to you. I gave the number of moles. So then it was very easy for you to understand. I mean, to do the sum, right? But I'm making it a little difficult. I can go for a variation without giving the number of moles. I could give you the mass of the solute I added, and then I can ask you to find the number of moles that I've added into the solution, right? So then I'm going to give you a question like that. Question number 2, mark it. 90 grams of glucose. You have to know the chemical equation. I mean, chemical equation now. C6H12 and O6. 90 grams of glucose dissolved in 2 decimeter cube of water. Find the concentration. So now I have this beaker. What I have done, I have given you how much of water, 2 decimeter cube of water. How much of glucose, C6H12O6? I have given you 90 grams and I have not indicated the number of moles. You don't know it. So to figure out, to work out the equation N equals CV, sorry, concentration equals number of moles over volume, concentration equals number of moles over volume. To figure out, to work out this equation, you need to know the number of moles, but still you don't know the number of moles. Instead, I have given the mass of glucose I have added into the 2 decimeter cube of water, and then you have to find out when you add 90 grams of glucose into this 2 decimeter cube of water, how much of moles of glucose will be added. That means simply you need to know, you need to calculate when you add 90 grams of glucose, how much of sugar moles would be, how much of glucose moles would be found in it, right? So then for that, this equation is not enough. We need to work out N equals M over M equation also, right? We need to figure out, we need to work out that equation also to find out the number of moles present in 90 grams of glucose, right? So then for that, you need to know the molar mass of glucose. So I will be indicating carbon's relative atomic mass, that is 12, hydrogen's relative atomic mass, that is 1, oxygen's relative atomic mass, that is 16. So I'm indicating that also as data, right? I give you data. So then what you have to do is to find out the molar mass, right? So you just imagine to work out this equation and to get the answer of this one. For this question, to get the answer, you need to know the number of moles. That means you need to know N. You have to find it out, right? Volume is given, that is 2 decimeter cubes. That is 2 decimeter cube, that's given, right? You have to know the molar mass. Molar mass of what? Glucose. Molar mass of C6H12O6. Molar mass of glucose, you have to know it. You can calculate it. And I have given the mass of glucose. Mass of C6H12O6 I have given you. That is what? 90 grams. I have given you. So what I'm asking from you is the concentration. Concentration, I don't know. That's what I'm asking from you. You need to calculate the number of moles. That you can do, of course, right? You have to calculate the number of moles also. Of course, that can be also done because I've given you the relative atomic mass of each element present in the glucose molecule, and mass of glucose is present. So what you have to do, first of all, see here, find out the relative atomic, find out the molar mass of glucose, right? Find out the molar mass of glucose. How to do that? So keep it in your mind. In this case, right, the molecule is C6H12 and O6. So relative atomic mass of carbon is 12. How many such carbon atoms are there in the molecule? 6. Relative atomic mass of hydrogen is 1. How many such hydrogen atoms are there in the glucose molecule? 12. Relative atomic mass of oxygen is 16. How many such oxygen molecules are there? 6. So altogether, it will come 180 g mole minus 1 as the molar mass of glucose. So now you know the molar mass of glucose, that is 180 g mole minus 1. All right, okay, fine. Okay. So first of all, what we need to do, we have to figure out, we have to sketch the diagram, what they have given. They have only given us the mass of glucose that they have added and the number, volume of solvent that they have used. So we need to know all of this to do the calculator and get calculation and get the answer. So in that, concentration is the fact that they ask us from, right? And then number of moles, of course, you can find out by working out N equals M over N equation. But to work out that equation, you need to know the molar mass of glucose. You need to know the molar mass of glucose, right? So to calculate the molar mass of glucose, we can use the relative atomic mass of each element. We did the calculation and found out the relative molar mass of glucose is 180 g mole minus 1, and we put it here. So then we have to work out this equation. What is the mass of glucose that they have added into the mixture? 90 grams. What is the relative? What is the molar mass of glucose? 180 g mole minus 1. Okay. Grams to gram cuts off. So 1 to 1 cuts off. Like as you know, like there are 1 9 for 9 and 2 9s for 18. So the answer would be 1 over 2 moles here. 1 over 2. That means 0.5 moles. Now you know when you add 90 grams of glucose into make sure you will be adding how much of moles? 2 moles. You found out that also, right? You found out that also. So now the things what needed to be found from the data that they have given us has been found, right? So they didn't give us the number of moles. We calculated the number of moles. How? By using this equation, N equals MOA, right? To get the number of moles, we had to know the molar mass of glucose. We actually use the relative atomic masses of each element in the glucose molecule, and we calculate the relative molar mass of glucose. And that molar mass of glucose was substituted in this equation here. And then we did the math and found out in 90 grams of glucose, there were 0.5 moles of glucose molecules. Now you know the equation of concentration equals number of moles over volume. You can work it out very simply. How do you work it out? Right? How do you work it out? That's very simple. Number of moles they have given us, that's 2, we found it out, 0.5, and the volume is 2 decimeter cube. And then you'll get the answer. Quickly work it out, guys. Quickly work it out. I'll show how this is done, right? I'll show how this is done with a different color. Oh, I don't have any different colors. Blue is it, right? Okay, this is done, right? How it's done? Concentration equals number of moles over volume. Number of moles 0.5 moles. This volume is 2 decimeter cubes. So divide, then you'll get 0.25 moles per decimeter cube. Space is the challenge on the virtual board.
Excuse me, sir.
Yeah.
Sir, I got dropped. Can I know what we're doing?
Yeah. Okay. So, did you write the question?
Sir, second question.
Yeah.
No, sir.
All right. Okay. So, write like this: 90 grams of glucose. 90 grams of glucose is dissolved in 2 decimeter cube of water. 90 grams of glucose is dissolved in 2 decimeter cube of water. Find the concentration of the glucose solution. Okay.
Okay, sir.
Okay, Upeka, now it's like this. Now, what they ask us, they tell us, right? They have given, can you see my pointer? Which is red?
Yes, sir.
So they tell us that they have given, they have used 2 decimeter cube of volume of water. Okay.
Okay, sir.
And they tell us that they have dissolved 90 grams of glucose, isn't it?
Yes, sir.
And they want us to find out the concentration, right? Now,
Yes,
if
sir.
you can remember, concentration can be found when you know the number of moles dissolved in amount of volume. Can you understand?
Yes, sir.
But here the problem is that they have not given us the number of moles of glucose that they have mixed. They have only indicated us the mass of glucose that they have mixed. Can you understand?
Yes, sir.
So that is the first step. You have to sketch this, indicate how much of volume that they have used for the solution, for the formation of the solution, and how much of things that they have dissolved, right? Okay. So we have now a problem to calculate the concentration of the mixture. We don't know the number of moles. Do we know the volume of the solvent that they have used?
Yes, sir.
Yes, 2 decimeter cubes. So now we have a problem with number of moles, right? So can you remember that we have studied an equation called N equals M over M that tells us the number of moles?
Yes, sir.
So in this equation, the mass of glucose what they have added is 90 grams.
Yes, sir.
Again, we have a problem of finding out the molar mass of glucose, right? So you know the
Yes,
glucose chemical formula of the glucose is C6H12O6, and I have given you the relative atomic mass of each element.
yes, sir.
Okay, the relative atomic mass of carbon is 12. How many such atoms are there in glucose? 6 carbon atoms. Relative atomic mass of hydrogen is 1. How many such atoms are there in glucose molecule? 12. Relative atomic mass of oxygen is 16. How many such oxygen atoms are found in glucose? 6. So altogether, you will find out 180 g mole minus 1 is the molar mass of glucose. Do you get it?
Yes, sir.
So then we found out the relative molecular mass of glucose. Sorry, molar mass of glucose simply. And then you can substitute it over here. Can you see that? Capital M of glucose.
Yes, sir.
And then when you simplify it, G to G cancel off. And then when you divide 90 by 180, that will be 0.5 moles. Can you understand?
Yes, sir.
That means we have found out this. When you dissolve 90 grams of glucose, you have dissolved how much of glucose moles? 0.5.
Okay, sir.
Now we know that we can find out the concentration. How? Because we know the number of moles, that is 0.5 moles, in how much of a volume that they have dissolved the 0.5 moles of glucose in 2 decimeter cubes. When you divide 0.5 by 2, you get 0.25 moles per decimeter cube as the concentration. Do you get it?
Yes, sir.
That's simple. Huh? So, but follow the procedure, follow the steps, so then you will not go wrong. Okay, quickly do that.
Okay, sir. Thank you.
Upeka, what happened? Is it a power failure or what?
So yeah, the power, it went and then it came back.
All right, it happened to me yesterday in the grade 6 class. Shanak, you were there? Nirmani, are there?
Hi, sir.
Okay, sir.
Elisha, you were there?
Okay, sir. I'm also done.
Right, okay.
Excuse me, sir.
Yeah.
Sir, yesterday's recording, like you uploaded it, right, to the Google Classroom?
Not yet.
Oh, okay, sir.
I will be doing it right. Right after this class. I have uploaded,
Oh,
but
okay.
to the YouTube, but not to the Google Classroom. I'll be like that. This is the. Now I have it in order, so then I'll be uploading it very quickly after this class.
Okay, sir.
Okay. And first of all, like I have to finish uploading the tute also. I have to do some corrections and upload it today. I'll be doing that today. Don't worry. Right. Okay. The next question. So we are okay with that question also. So Upe, are you done with that?
Yes, sir.
Okay. Right. Okay. Next part. Vincent, hari neda? Ek awulak na neda? Right. Okay. So the next question. Question number 3. Okay. All right. So it's like this. Okay. Quickly write like this. 80 grams of sodium hydroxide. 80 grams of sodium hydroxide was dissolved in. Hold on. Okay. Hold on. 80 grams of sodium hydroxide was dissolved in. No problem. 80 grams of sodium hydroxide was dissolved in 500 centimeter cubes of 80 grams of 500 centimeter cubes of water. $500 centimeter cubes of water. Find the concentration of solution. Now I reduce the number of sums that you have to do because you can do the sums in the worksheet. I've given you enough sums. Right, 80 grams of sodium hydroxide is dissolved in 500 centimeter cubes of water. So you have a problem now because the SI need to substitute volume is decimeter cubes, not centimeter cubes. Okay. Right. So sketch, go for the sketch. A little sketch is, I think it's important, but I don't know how do you feel it. It's important so you don't go wrong. Okay. Right. So how much of volume what you have used? 500 centimeter cubes. Right. 500 centimeter cubes of water. And then I've given you sodium hydroxide, NaOH. That is actually 80 grams. Okay. So I don't know the number of moles of sodium hydroxide which is used here. So then out of this, what I know, number of moles, I don't know. They ask us from the concentration that I don't know. Number of moles, of course, I know that I can find it out, right? So the volume they have given us 500 centimeter cube, but it still needs a modification. Molar mass of sodium hydroxide, you can calculate it. Mass of sodium hydroxide, mass of NaOH, they have given that is 80 grams. Okay. Molar mass of NaOH, you can find it out. Okay, you can find it out. So I'm telling you this relative atomic mass of sodium, that is 23. Sodium relative atomic mass, that is 23. Relative atomic mass of oxygen, you know it, that is 16. Hydrogen's relative atomic mass, you know it, that is 1. Okay, go for the calculation. First of all, you have to find out the molar mass of sodium hydroxide, NaOH. Go for that very first. Right. So in sodium hydroxide, one sodium atom is there, one oxygen atom is there, and one hydrogen atom is there. Altogether, it comes as 40 g mole minus 1. Did you get that? So I found out for molar mass of sodium hydroxide, that is 40 g mole minus 1. Did you find that? Did you find that? Hello.
Yes, sir.
Right, Elisha, Shanuki, Upeka, did you find that?
Yes, sir.
Okay, right.
Yes, sir.
So then molar mass I have found out. Mass of sodium hydroxide I know. So then I can calculate the number of moles. Using N equals M over M, I can calculate the number of moles. Mass of sodium hydroxide added is 80 grams. Molar mass of sodium hydroxide is 40 g mole minus 1. Grams to gram cuts off, and then it comes as 2 moles. Number of moles equals 2 moles. So you have found out the number of moles or the 2 moles. So now the equation can be finalized with concentration equals number of moles over volume, but you have a problem with volume. As you all know that you have to substitute the volume in decimeter cube, but here you have a problem. I've given you the volume in centimeter cubes, right? Okay, you do the math until up to this, so then I'll go for another page and I'll do the final sum in the next page. So you have a problem to work out the final equation. N equals C, concentration equals number of moles of volume. That's because I've not taken 1 decimeter cube. Or more than decimeter, I have not taken decimeter cubes of volume. I've taken only 500 centimeter cubes, but thing is you can't indicate the volume in centimeter cube because it's standard to use unit to use for their volume is decimeter cubes. So you need to convert and see how much would be 500 centimeter cubes in decimeter cubes, right? So as you all know, like if you have 1000 centimeter cubes of 1 decimeter cube, right? So what you have to simply do to find out how many decimeter cubes will be there in 500 centimeter cubes will be like you have to divide 500 centimeter cubes by 1000. Then only you will find out how much of decimeter cubes will be there in 500 centimeter cubes, right? So are you up? Are you okay up to this? Are you done up to this? Can I move on? Hello.
Yeah, sir.
Right. What about the others? Bima, Harida, Malli?
Hi.
Right. Elisha, Harida, Upeka, Harida?
Yes, sir.
Shanuki, Harida? Shanuki?
Yeah, sir. Yeah.
Okay. Right. So then this is the thing. Concentration equals number of moles over volume. Number of moles, how much? It was 2 moles. Yeah, 2 moles. 2 moles. Now the volume is a problem. I can do like this: 500 centimeter cubes divided by 1000 will be equal to decimeter cube. Because when you divide 500 centimeter cubes by 1000, you will get the decimeter cube value. Right? Not the centimeter cubes, are centimeter 500 centimeters cubes. When you divide it by 1000, you will get the decimeter cube value. Right? So then you can write like this, or else what you can simply do, you can divide 500. You can divide 500 centimeter cubes by 1000 and do the math and get the decimeter cube. You'll get like 0.5 decimeter cube, right? And then you can substitute it over here as a volume. Can you understand? Or else within the sum you can do the conversion, or else you can do it on another place and then you can bring it out here as the decimeter cube final value. Can you understand? Anyway, we have to substitute the volume in this equation as a decimeter cube, but not as centimeter cubes. Are you guys clear with that? Hello, are you guys clear with that? So if they indicate the volume instead of decimeter cubes in centimeter cubes, what you simply have to do, divide the given centimeter cubes value by 1000 to get how much of decimeter cubes would that be equal to the given centimeter cube value. Can you understand that, guys?
Yeah, sir.
Right? So it's simply like this. Now you know, in 100 centimeter cubes will be equal to 1 meter. They ask how much would be 200 centimeters. What do you have to do? Divide 200 centimeters by 100. Then you will get 2 meters. Do you understand it? If they ask 50 centimeter would be how much of meters? So divide 50 centimeters by 100. Then you will get 0.5 meters. Do you understand? Familians, are you okay with that conversion?
Yeah, sir.
Other two? Ellie, what about you?
Yes, sir.
Yes, sir.
Right. Okay. So then that's what we really need here. So that can be done separately somewhere and bring the final decimeter cube converted value over here. Or else you can do the math over here and do the simplification conversion on the even within the sum itself, right? So if you did do it like this, I could take this value over here. That means 2 moles divide by 500 into 1000 decimeter. Okay, so this is 2, this is 1, 2 into 2 is 4. That will be 4 moles per decimeter cube is the concentration. Are you guys clear with that? Done with that?
Yeah.
Did you understand? I'll give you another sum, don't worry. Go for the simplification and I'll give you another sum. Right. Okay. Next question. Next question. I'll give you one more. Right. Right like this. Right. Uh, okay. 32 grams of methane. 32 grams of methane. I'm not going to give you anything. I'm going to wait and see what you do. Right. Okay. Question. 32 grams of methane. 32 grams of methane. And that is CH4. Okay. Right. CH4. So then I'll give you the carbon's relative atomic mass, that is 12. Hydrogen's relative atomic mass, that is 1. Okay. 32 grams of methane was dissolved in 250 centimeter cubes of water. Find the concentration of the solution. Find the concentration of the solution. Take a time and do the math. Done. Right. So what do they tell us? They tell us that they have used 250 centimeter cubes of water. Okay. 250 centimeter cubes of water to dissolve 32 grams of methane. Okay. So we need to find out the number of moles. We don't know. We need to find it out. Volume we know, that is 250 centimeter cubes. We need to find out the molar mass of CH4. That can be done. They have given us mass of CH4, that is 32. Okay. Concentration is what they ask us from. Okay. So work out the molar mass of methane. Molar mass of methane. So carbon has one carbon atom and 4 hydrogen atoms, 1 into 4, right? That is going to be 16. 16 g mole minus 1 would be the molar mass of methane. Okay. And then you can find out in 32 grams of methane, how many number of moles would be present, right? So you can work out N equals M over, sorry, simple M over capital M. Given mass is 32 grams. Molar mass of methane is, given mass is 32. Yeah, molar mass of methane is 60 g mole minus 1, 16 g mole minus 1. So simply you will have 2 moles. 2 moles, 2 moles. So you know the number of moles of methane will be added when you add 32 grams of methane. And then molar mass of methane, we found it out, 16 g mole minus 1. Then we need to find out the concentration. Right, we need to find out the concentration. I'll be doing it on the next page. Are you guys done up to this? Put up your hand those who have done up to this. Okay, Eli, Upe, Eli, did you get stuck somewhere?
No, sir. Okay.
Are you okay, or do you find anything difficult?
No, sir.
Okay, sure.
Yeah.
Right. Okay, so then N equals, sorry, concentration equals number of moles of volume. Number of moles, 2 moles was found, and 2 moles were found, and volume was 250. Then divided by 1000 to express it in decimeter cubes. So simply you can do 2 moles, leave 250, take 1000 onto this side, and decimeter cube as a minus. So for 251, for this one, 4. 4 into 2 is 8 moles per decimeter cube. This is the answer you should reach. Have you got this answer? Have you got this answer? Right. Right. If you are okay with this, then you know probably all the variants that you can come up with the calculation part of this concentration. Right. We have some more sums to be done in the worksheet. So let's go through them also.
Excuse me, sir.
Yeah, Muta.
Sir, did you send the PDF of that worksheet? No, right?
I think yes.
Ah, okay, sir. So are you gonna do it today? I
Not
couldn't
today.
take a
Not
picture.
no, not today. Not today.
Ah, okay, sir.
We will be discussing it. I have to discuss it. Basically, on this Thursday night, we'll be talking about the revision MCQ part of the worksheet. Mixer, yes, worksheet I've submitted. I will be talking about the revision MCQ of living tissues, and then I'll be talking about short note. Can you remember that I submitted a worksheet on living tissues also? And then I asked you that would be the short note if you go for that. I mean, if you
Okay,
do that, that would be the short note of that lesson. So then I'll be discussing that part also. So then
Okay, sir.
likewise on the next Thursday, I'll be like discussing all the things what I've done, I've submitted. I've discussed about some MCQs regarding photosynthesis, living tissues, and then about this also, these sums also. So I'll dedicate, the Thursday will be dedicated for those activities.
Okay, sir.
Okay, right. So then when you come up to this, right, next thing, so we are done with this calculation, and then write a point. So we are out of this calculation, right? Then write a point, kind of a heading, a subheading. Chemical composition of a mixture depends on 2 factors. It's kind of a heading. Chemical composition of a mixture depends on 2 factors. Chemical composition of a mixture depends on 2 factors. Okay. Out of that, the Roman number 1 is amount of solutes in the solution. Okay. So to prove you that, I would take like this. I would take two beakers. That's A, and this is B. I would take the same volume of water here. I would take, let's say, 1 decimeter cube of water for the simple calculation comfortness. I will take 1 decimeter cube, and then I'm gonna dissolve actually 40 grams of sodium hydroxide here. Okay, that is 40 grams of sodium hydroxide here. No, I'll make it like 20. I'll make it like 20 grams of sodium hydroxide here, and then I'm gonna dissolve actually 80 grams of sodium hydroxide here. Okay, so what I have dissolved, I've taken 2 samples of water, that is 1 decimeter cube, and I've dissolved 40 grams of sodium hydroxide in one beaker A. Sorry, 20 grams of sodium hydroxide in beaker A and 80 grams of sodium hydroxide in beaker B. Okay, so I told you the concentration of a mixture depends on 2 factors. The first factor what affect the concentration is the amount of solutes in the solution. Okay, and then we are going to figure out how would it affect the concentration of the solution. And for that, you need to find out the concentration of the 2 solutions individually, right? So you'll have a trouble. You have to calculate the number of moles in each mixture, and then you will have to substitute the value and get the concentration of each solution. Do that for me. Then you will yourself understand what could be the impact that is given on the concentration of a solution by the amount of solutes dissolved. Now in these 2 mixtures, I've used the same volume of water, same volume of solvent. What I have variated is the amount of solutes what I have dissolved. In the first beaker, you can see that less amount of solutes are dissolved. Same solute, but in a higher amount, like 80 grams. You have like it's many times greater than the initial situation, right? You absorb 80 grams of sodium hydroxide in the second beaker, and then let's see how would the mass of the solute dissolved in the mixture would affect the concentration, right? Quickly go for that value. Now you can obviously understand when the mass of the solute dissolved in the solution increases, the amount of moles, the number of moles dissolved in the solution increases. When the mass increases, the number of moles present in the mass of the solute increases. That would obviously increase the concentration, right? So you do the calculation, will you? So now you know the molar mass of sodium hydroxide. You have calculated it. Molar mass of sodium hydroxide. Now you know it. Don't do the calculation again. That is 40 g mole minus 1 we did previously. So then what you have to do? First, what you have to do? We have to find out the number of moles of sodium hydroxide here. N you have to calculate mass over molar mass. Mass is what? 20 grams. How many more? What was the molar mass of sodium hydroxide? 40 g mole minus 1. So gram to gram cancel, 0 to 0 cancel. This is 1 over 2, right? So you have 0.5 moles here. 0.5 moles here. So don't go for the concentration equals number of moles over volume. Concentration is what? Number of moles is what? 0.5 moles. Volume 1 decimeter cube. Okay. So then you'll get 0.5 moles per decimeter cube. That is the concentration of the first solution. Second, do the math again, right? Do the math again. N equals M over M. Given mass of sodium hydroxide, that is 80 grams. Molar mass of sodium hydroxide, that is 40 g mole minus 1. So you'll find out that there are 2 moles in 80 grams of sodium hydroxide. Concentration, number of moles 2 moles, volume 1 decimeter cube, right? So then you'll get a concentration as 2 moles per decimeter cube. Now you can understand when you are not variating the volume, but if you have when you only have a variated the amount of solute dissolved in the mixture with higher amount of solutes contains more number of moles. That means the concentration of that mixture is high, right? Concentration of that mixture is high, right? So simply do this calculation. I'll come for the conclusion. Can you understand, guys? When you dissolve more solutes in a solvent, right, the concentration of the solution is going to be high because you are adding more number of moles. When you add more amount of more mass of solute, can you guys understand that fact? Hello, I want a response. Can you understand that?
Understood, sir.
Yeah, Upeka, Elisha,
Yes, sir.
Nirmani.
Okay, sir.
Okay, Bhimsen.
Yes,
Right. Okay. Okay, let's write the conclusion, shall we?
Okay, sir.
Lamai, shall we? Right, okay. When the amount of solute increases, 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 the concentration of the solution increases. Yeah, concentration of the solution increases. Concentration, composition, both the same. Concentration of the solution increases. Concentration of the solution increases. Right. That is the first fact. How would the amount of solute affect the concentration when you increase the amount of solutes, right? When you increase the amount of solutes, the concentration increases. Okay. So the second fact, find the second fact, number two, volume of the solvent. Second fact, volume of the solvent. Okay, now what do? I take two beakers, right? The first beaker contains 1 decimeter cube of water, that is beaker A, and the beaker B contains actually 2 decimeter cube of water. 2 decimeter cube of water, right? That's beaker B. And into one first beaker, I add, now I am not going to make it complicated. I'm going to make it dissolve sodium hydroxide. I'm going to dissolve the same thing, sodium hydroxide. I'm going to add 40 grams. The same as I will be adding here also. The second beaker sodium hydroxide, I will add 40 grams, right? 40 grams. So then I wanted to find out the concentration of both of them. Now, First, let's calculate the number of moles of sodium hydroxide found in 40 grams. N equals M over M. Given mass of sodium hydroxide is 40 gram, molar mass of sodium hydroxide is 40 g mole minus 1. So simply you can understand in 40 grams, 1 mole of sodium hydroxide molecules are there. Then go for the calculation over here, concentration in this. Oh, sorry, volume or number of moles or volume. Number of moles of volume. Here also concentration because number of moles of volume. Right. In the first case, 40 grams add kala tiyena, so 1 mole of sodium hydroxide is here. How much in 1 decimeter cube? So how much would be the concentration? 1 mole per decimeter cube. Second situation, 1 mole of sodium hydroxide is here. Yeah, true. How much of volume? 2 decimeter cube. So what would be the answer? 1 divided by 2 is 0.5 moles per decimeter cube. All right. Now what happens here? When you increase the solvent volume, when you have the same amount of solute, when you increase the volume of the solvent, the concentration decreases. Right, the concentration decreases. Now, if you have seen it, I have added the same amount of sodium hydroxide. That means I have added 1 mole of sodium hydroxide into beaker A and into beaker B also 1 mole of sodium hydroxide. But I have used 1 decimeter cube of volume of solvent in beaker A, and I have used 2 decimeter cube of volume of solvent in beaker B. So though the same amount of solute is mixed, when you increase the volume of the solvent used to make the mixture, the concentration of the solution decreases. That's right. That's right.
So the conclusion, right?
Yeah, the conclusion. When the volume of the solvent increases, when the volume of the solvent increases, when the volume of the solvent increases, the concentration decreases. The concentration decreases. When the volume of the solvent increases, the concentration decreases. When the volume of the solvent increases, the concentration decreases. Is that what I said? When the
When the
volume of the
volume of
solvent
the solvent increases, the concentration decreases.
decreases. Yes. Done.
Yeah, sir.
Right. That's it. So we are done with the part. So මෙතනින් පස්සේ we spoke about preparation of a standard mixture that we did yesterday, I guess. අපි ඊයේ කරා නේද?